Good morning, friends. This is a series of lecture for T.Y.B.Sc Analytical Chemistry Semester 6 student. The course of this analytical chemistry is CH611A. The chapter number 6, we are going to study that flame emission spectroscopy. Now in that flame emission spectroscopy, we have already learned about the principle, introductory part, and the basic about the type of flame, the factors affecting the flame temperature, type of the flame, type of the burner utilized in the flame emission spectroscopy. Now in this lecture we are going to learn about the total consumption burner, that is a TCB. Now in that TCB, this is the block diagram of the total consumption burner, or indicating the which indicates the outlet for the oxidizer inlet, one inlet for the fuel, and another sample introduction capillary. Now these three parts may be interchanged as by the manual, or you can say by operating procedure. That means fuel inlet should be here, only oxidizer inlet should be here, sample introduction should be here or here. Now this may be interconvertible according to the situation or application. Now here this is the flame. Now in that flame, this is the tip of the burner, and this is the flame, and this lower part is nothing but the burner. In that burner there are the three tubes or three passages where oxidizer inlet will come into the flame, fuel inlet will come into the flame, sample introduction capillary which will give the sample towards the flame. Now this is the theory part associated with the total consumption burner. In total consumption burner, sample solution, fuel and oxidant gases are allowed to pass through a different passages or tubes. So this, according to this first point, there are the three tubes where sample solution, fuel and oxidant gases are allowed to pass into the burner or into the towards the flame. Now in total consumption burner, the second point, in total consumption burner, sample solution, fuel and oxidant gases are mixed and combusted at the tip of the burner. Now this is the tip of the burner, and at this point sample solution, fuel and oxidant gases are mixed. Here the mixing takes place of the three, that is a sample solution, fuel and oxidant gases, and they will get combusted at this point, and there is a production of the flame takes place. Now this flame breaks up the sample solution. The third point is that the flame breaks up the sample solution into tiny droplets, followed by evaporation to form the residue, followed by reduction to atoms. Now what is the role of the flame? That flame the flame breaks the sample solution, and that sample solution will be get converted into tiny droplets, and these tiny droplets get evaporated to form the residue, and this again residue will be get reducted, or reduction takes place, and it will give the atoms. These atoms are nothing but the free neutral atoms or number of excited atoms, which is given by the flame into the total consumption burner. Now there are the two advantages of the total consumption burner. Here the first is that it has almost 100% atomization efficiency. So that means here almost 100% atomization efficiency means the sample solution, whatever the amount of the atoms present in the sample solution, all the atoms should be get atomized and converted into neutral free atoms, which will be get excited by the flame. So the production of the 100% free neutral atoms means 100% almost efficiency. So that is the best advantages of total consumption burner, that it has almost 100% atomization efficiency. The second point of the advantages is that combustible gasoline can be spreaded safely. Now here gasoline is we know that gasoline is nothing but the petrol, and petrol is dangerous and it is highly combustible, but the total consumption burner provides a feature that the prediction, or can say the spreaded property of the gasoline, that will be monitored or controlled with safety. So that is all about the total consumption burner, which will be the base point or first point of the instrumentation of the flame emission spectroscopy, the chapter. Here the total consumption burner gives the production of the flame, and this flame will be utilized to give the free neutral atoms or free neutral excited atoms, and these are the two advantages of the flame total consumption burner, which is utilized as a burner in flame emission spectroscopy. With this content I conclude this lecture. Thank you very much for your patience listening.